Hello and welcome to Permutations Part 2. I'm starting off with an example where we have 10 different flags and we're going to choose 2 of them to hoist up. And in this example we have to understand that if we had a flag A, say, over a flag B, we consider that to be different, so it differs from if we had a flag B on top and a flag A underneath. Okay, so that it's an important thing to understand. Again, order matters here. Okay, this has a different meaning than this, so we have to count it as a different arrangement. So what we could do is we could say, oh yeah, we could do this with fundamental counting quite easily and just say, well, the top flag we have 10 choices, and the bottom flag, we would have 9 choices. Okay, so, pretty easy with fundamental counting. However, I'm going to use the other permutations formula, the one that looked like this, N pick R. So in this case, we have 10 flags to choose from. We're going to pick 2 of them. Now, in the formula, that means I have to have 10 factorial on the top, and 10 minus 2 factorial on the bottom. Okay, now I could just work this out, or I could have actually done this on the calculator. If I were to continue working it out, I'd have 10 factorial over 8 factorial. And I'm going to use a little trick here. 10 times 9 times 8 factorial, all over 8 factorial. Guess what cancels? Hey, look, I can get rid of those 8 factorials, and I'm left with 10 times 9, which is 90 different signals that we could send with those flags. All right. Well, I know what you're thinking. You're thinking, hey, wasn't this quick and easy? And yes, but you still have to know your permutation stuff, because sometimes fundamental counting isn't good enough. All right, on to the next example. Here's a fine example of where fundamental counting won't do it for you. Somebody comes along and says, n pick 2 equals 110. So this is given to you. And then you're supposed to solve for n. Solve for n. All right, so if you don't know the formula, you're sunk. So basically, I have to go and build this and say, well, I got n factorial, according to the formula, and underneath I have n minus 2 factorial, and I'm told that equals 110. Now, here's how you unravel these type things on the left side. Okay, what we want to do is try to work it down so we can get rid of the whole factorial stuff. So what does factorial mean? Well, on the top, you have n times 1 less than n. And then the next thing it's going to multiply by is 2 less than n. And this will go on forevermore. So you say factorial. Okay, so that's what the top looks like, kind of expanded a little bit. And the bottom I could expand, but why should I? I can see, aha, that's perfect. I can cancel the n minus 2 factorials. So here's what I now have. I have n times n minus 1 equals 110. Well, I'm going to expand this out, because this to me looks like a nice little quadratic equation. I got n squared minus n equals 110. How do I solve it? Well, like I solve any quadratic equation, make sure it equals 0, and then I could use a quadratic formula. Maybe it even factors. In fact, I think this one factors. So let's have a little look. If it factors, it would look like this. So I'd have n times n. Then I need 2 numbers that multiply together that make negative 110 that add up to negative 1. So I'm thinking negative 11 and positive 10. Now that gives me the following suggestions as answers. 11 and negative 10. But hold on. If you look at the original question, this came from n pick 2. So there's n items. You're going to pick 2 of them. How can you pick 2 items from negative 10? Doesn't work. So So we have to reject that one. So there's only one correct choice for n, and that is 11. And that's where I'm going to stop talking about permutations for now.